Hi students, welcome to all fours e-learning chemistry classes for junior inter. The running chapter is stoichiometry and now we are in session number 32. In previous sessions we discussed about the stoichiometry. In that stoichiometry we learn about the balancing equations, and thereafter we learn about the oxidation states, and by oxidation number method and ion electron method how to balance the equation, and before that the mole concept and the stoichiometric calculations, all these we discussed, and finally we did some numericals related to idiometric equations, is it not? And now with all these, after covering all these different topics in our previous discussions, now we are entering into a new topic, that is concentration terms, expressing the concentrations. It is a new topic in stoichiometry, and from this onwards actually it is interlinked concept. The same concentration terms you will come across in other chapter, that is nothing but liquid solutions in second year, is it not? So that's why it is better to learn thoroughly, where you can feel easy to calculate the numericals related to liquid solutions in coming days. That's why, that too, one more important thing is concentration terms in coming physical chapters like thermodynamics, or when it is related to equilibrium or ionic equilibrium, in all these also we are using the concentrations. That's why it is of somewhat very interesting topic, as well as it is of having its priority in different chapters. So that's why I suggest you be thorough with these concentration terms. Something you might learn regarding these concentration terms in your lower classes, but actually already you know from the previous experiences, that is from previous sessions or from previous videos, what you learn in 10th class is very minute when compared to the syllabus that present in our 11th class, is it not? And here also I am going to provide you the details of the concentration terms, and where, what is concentration and where we are using it, and what are different terms used to express the concentrations, all these, and how to find that concentration, what are the rules, if any laws are persisting in these concentration terms, then what are those rules, all these we have to learn in detail, because they are going to play a very important role in coming chapters. Clear? And now here first let me give concentration. For this concentration, for this concentration, where we are using the word concentration, first of all we should look it. It is nothing but it is related to solutions, and when we are using the solutions, then automatically we have to use the word concentration. And first, so that means to learn the concentration term, first we should understand what is a solution. Solution is nothing but a homogeneous mixture of two or more components when present in the given mixture. It is, if it is homogeneous means they exist only in one phase. Let me give one best example to understand. Sugar, actually it is in solid state, is it not? It is in solid condition. And water, it is in liquid condition. Now when sugar is dissolved in water, it is nothing but sugar solution. Why we are considering sugar after dissolving in water, it is considered as sugar solution? Because this sugar solid state or solid phase is disappearing. Only one phase, that is nothing but liquid phase we can observe only liquid phase of this mixture. That means it is becoming homogeneous, is it not? Similarly, salt when dissolved in water, not only this one, any, but here we are considering the best example to explain this, is it not? And now in this homogeneous mixture, when two or more components involved, just you remember, actually when two components involved, it is known as two components when involved, it is known as binary solution. Binary. And you remember our syllabus is confined to this binary solutions. So binary solution, sugar solution is a binary solution because only two components are present. And next one, three components when present. When three components present, it is ternary solution. And when four components present, it is quaternary solution. Unlike that. Clear? And so on. But our concentration is related to binary solution. Binary solution means only two components involved in this solution. Clear? A homogeneous mixture of two components, when two components involved, it is known as binary solution. Clear? And now we have to learn about what are the two components that involved in binary solution. Immediately after learning this definition for binary solution, immediately our next question is nothing but the two components will involve in this binary solution, no doubt at all. And now what are those two components that present in this binary solution? Is it not? That is our next question that we can think about. And here let me give that one. Components in binary solution. Binary solution. And actually when we discuss about the solution, in your lower classes already you studied about the two components present in solution. One is nothing but solute and the other one is nothing but solvent. And first, these are the two components that present in binary solutions. Clear? And now different types of solutions are there, classification depending on the phase of the solute and solvent. And first let us define what is a solute, which is considered as solvent in a solution. In your lower classes what they are, say for example here if it is given sugar plus water, simply you can consider sugar is solute and water is solvent, like that, because these are well familiar solutions. That's why. And by definition, what is solute? In lower classes you might learn that the component which is less in quantity that is involved in the sugar form, that is solution formation, is solute, and the component that is present in large quantity, that is nothing but the solvent. Here why sugar is solute? You are considering it is as because it is less in quantity, and water is taken in more in quantity, that's why you can say that it is solute and it is solvent. But actually the definition is not like that, not on quantity based. Just you remember, it is very important, it is a misconcept. Quantity based definition is wrong. Let me prove it. Say for example, if you visit any sweet shop, if you observe how the sweets are prepared, there you can take you can observe that 3 to 4 kgs of sugar is dissolved in even 1 liter of water, less than 1 liter actually. So when that much of sugar, that is 3 to 4 kgs of sugar, when dissolved in 1 liter, if quantity based is correct, what we have to consider, more quantity sugar is present and hence it is solvent. Are you accepting this? And less quantity of water is present, hence it is solute. Can you accept when I define these two, or when I assign that sugar is the solvent and water is the solute? Can you accept? You can't. But you are defining that more quantity component is sugar and less quantity component is that is more quantity less quantity component is solute and more quantity component is solvent. If your definition is correct, here my assigning is correct, because when 3 to 4 kgs of sugar is dissolved, is mixed with water, it is dissolved, and here it is more in quantity. When more in quantity, as per your definition, it is solvent, and water is less because only 1 liter is there, and hence it should be the solute. But you are not accepting. Why? That's why I am saying it is the quantity based definition is wrong. Then how to define? Just you observe, sugar, it is solid, whatever the quantity it may be. it is solid, and water, it is liquid in state, is it not? And now of these two, when mixed, one is losing its phase, it is converting into the phase of the other, and which is losing when the sugar is dissolved in water, what we are considering sugar syrup. In that sugar syrup, you can say it is in liquid state, that liquid is nothing but water. So here also water is solvent and sugar is solute, irrespective of the amounts they are taken. Here we can define solute and solvent in different manner. One is the component which loses its phase and is solute, and the component which retains its phase is solvent, is it not? But one more definition is solute is completely dissolved. Solute is the substance which dissolves, and solvent is the substance in which solute is dissolved. Again I am repeating, solute is the substance that dissolves in solvent, and solvent is the substance in which solute is dissolved. Here solute, sugar is dissolved in water, but not water dissolved in sugar, is it not? That's why the substance which is dissolved is solute, and in which it is dissolved is solvent. Clear? So these are the two components. Just you remember, you forget about the lower class definition, that is a lower amount of solute, lower amount of the substance or component is solute, and a higher amount of substance when present, it is solvent, like that. If we are defining, it is totally wrong, is it not? And now let us go for this binary solution. Already now we are confining that solution is having two components, one is solute, the other one is solvent, and then we are considering solute is nothing but the substance which is dissolving, and solvent is nothing but the substance in which solute is dissolving, is it not? And now concentration, the term concentration, what is concentration? And now let us consider, here we are taking binary solutions. Just you remember, our concentration, that is nothing but our syllabus is related to this binary solution. Our syllabus is related to binary solution, is it not? And now this, when it is binary solution, depending on the concentration, these are of three types. One is nothing but saturated, and then second one is unsaturated, and third one is supersaturated solutions. Saturated, it is nothing but, say for example, if we are considering 20 ml of water, let us assume like this, at a given temperature, that is nothing but at 25 degrees centigrade room temperature, if the maximum dissolvable substance in this one is, say for example, 10 grams. 10 grams of any substance X is able to dissolve in this at 25 degrees. Let's assume like that. That is the maximum quantity that we can make dissolved in this 20 ml. Okay. Now, if the 10 grams of the substance is completely dissolved in 20 ml, that is, it is dissolved to its maximum extent at a given temperature, then it is known as saturated solution. If the maximum extent, how much it can dissolve in that one, is nothing but 10 grams, but now the substance that is dissolved is less than the 10 grams. The substance that is present in that dissolved condition is less than the maximum extent. Are you following? It is assumption only. Just you observe. It is, let us assume that maximum quantity that can be dissolved in 20 ml of water at a given temperature is 10 grams. It is maximum extent, is it not? And now, if that maximum extent of the substance is completely dissolved, then it is saturated. If the substance that dissolved in 20 ml at this 25 degrees centigrade is less than this 10 grams, then it is known as unsaturated solution. And now, the maximum extent is nothing but, again it is, we are considering at 25 degrees centigrade, we are considering 10 grams is the maximum extent. But here the substance that is dissolved is here the substance, dissolved substance is less than 10 grams. Here the dissolved substance is more than 10 grams. If it is greater than 10 grams, then the solution is known as supersaturated solution. Now again you may have the doubt, sir, already we are assuming that 10 grams is the maximum extent at 25 degrees centigrade. So when maximum extent is 10 grams, how it is possible to make more than 10 grams to dissolve in this 20 grams 20 ml of the solvent? That may be automatically it is the doubt that we can arise. Here you observe at 25 degrees centigrade, actually we can't dissolve more than 10 grams. 10 is the maximum extent. But here what I am doing is, slowly I am heating the solution. You know, when the solution is heated, more and more solute can dissolve. Like that, I make 15 grams, for example, is made to dissolve at high temperature. At high temperature, say for example at 50 degrees centigrade or like that, when I heated, this 15 grams is dissolved in that. Clear? And then automatically you may raise the question, sir, now temperature changed, but the definition is given at a given temperature. Then when temperature change, the definition is not working out, is it not? And in such a case, that just you listen here at 50 degrees, and why I am heating that one? To make more and more solute to dissolve. Okay, it is dissolved. Now I am cooling that solution to normal temperature. Slow cooling, not sudden cooling. If sudden cooling happen, then 10 grams will retain, the remaining 5 grams will come out. No doubt at all. But here I am not doing like that. Just after dissolving more than the maximum extent by heating the solution, slowly I am making it to come to room temperature, that is at 25 degrees centigrade. Now that will possess more than 10 grams, that is 15 grams of solute is present in that 20 ml. First heated, but finally what is the temperature what we are observing? 25 degrees. Now excess is present. That type of solutions are known as supersaturated solution. And you remember, supersaturated solutions are highly unstable. They are also considered as metastable. Any disturbance if you are creating, if shaking or further heating or further rubbing of the vessel walls, all these, any disturbance if we are creating for the supersaturated solution, immediately the excess amount will come out and that solution will become saturated. Just you remember, when it is supersaturated, we should not create any disturbance. If any disturbance is created to that solution, immediately that excess of the amount which is dissolved at high temperature, which is made to dissolve at a high temperature, is coming out. And now after the disturbance, the maximum amount that can exist in that one, retain in that one, is again 10 grams. So like that, supersaturated solutions are prepared simply first by heating and then by slow cooling to room temperatures. Clear? That is about this, depending on the relative amounts of solute and solvent. If sufficient amount of solute is dissolved in the given amount of the solvent at a given temperature, it is saturated. If more than that present, supersaturated. Less than that maximum quantity is present, it is unsaturated. Clear? Now concentration is nothing but the term used to express relative amounts. Just you observe here, relative amounts of solute and solvent in a solution. To express the relative amount, just what we are considering in previous, just what we discussed in classification, such certain amount is dissolvable, and if that maximum extent is present, saturated. If it is present less than that maximum extent, it is unsaturated. If it is present more than the maximum extent, it is unsaturated. Like that, we are defining only saturation, unsaturation and supersaturation condition. But how much is present? how much of solute is dissolved in how much of the solvent, relative amounts. That is nothing but always the ratio. That relative amounts, when we are considering for the solute and solvent, to express this relative amount, the terms used are nothing but concentration terms. They are concentration terms. Concentration is nothing but expression of relative amount of the solute and solvent in a given solution. Clear? And now let us consider the amounts. Already we completed till now in stoichiometry the amounts of the substances, how to measure. We learned it is nothing but so many units are used to express these amounts. It is nothing but we can consider, say for example, here solute is there and here solvent is there, and we can express this solute in weight, that is nothing but grams, and here also it is weight in grams, and it is in volume, here it is also in volume, or it is in weight and it is in volume, or it is in moles and this is also in moles, or it is in moles and it is in volume, or it is in equivalent weights and it is in volume. Like that, different we can use, and that too different combinations we can consider. Here when both these two are considered, weight and weight, one concentration term, volume and volume, another concentration term, weight and volume, another concentration term, moles relation, another concentration term, and then moles and volume, one more concentration term, and then equivalent weights and volume, another concentration, and one more is nothing but here the solute may be considered as the moles and the solvent is in weight. This is also one more concentration term, and when it is in such a concentration term, different expressions you can observe: weight, volume, weight, volume, moles, volume, equivalent volume, or moles in weights. So many expression terms are there, is it not? And now we are going to give a special term for these different expressions. The term is nothing but concentration term. Are you following all this? The term which is of relative, no doubt at all, concentration term is a common, concentration is nothing but a common word, but that concentration term is different. Why? Because the expression of relative amounts we are not considering always the same. Depending on the feasibility and flexibility of these different amounts, we are expressing the solute and solvent in different units. In such a case, when they are expressed in different units, they are giving rise a different term. Those terms which are of related to each of these different expressions are known as concentration terms. And now in our next session we are going to learn what are different terms used to express the relative amounts, and ultimately it result to what concentration term. What is the concentration term? That means first we learned that, but later on, say for example, let me give molarity. Molarity is a concentration term, but once we learn about that molarity is nothing but solute in moles and solution in volume. And when the solute is in moles and solution in volume in liters, we can consider it as molarity. So by observing or by studying the molarity, we have to consider the relative amount unit. Actually, after learning, we are using in a reverse manner. Clear? So what are the different concentration terms that are useful in finding the relative amounts and the units for that concentration terms? All these and any laws related to this, all these we will learn in the next coming session. Okay, thank you.